Hello everyone, myself Vaishnavi Srivastava. I am from National Institute of Technology, Nagaland, presently in my pre-final year of bachelor's program, doing majors from Electrical and Electronics Engineering. This is my first YouTube video which I am making to complete my internship on embedded systems under Emertxe Technologies. So now I am starting my presentation. My project is microwave oven simulation. Now I am starting. My contents are C programming and embedded C, microcontroller and microprocessor, embedded system, and finally project description. Starting with C programming. C programming is a general purpose, procedural, imperative computer programming language. C program is used in system software development, embedded software development, OS kernel development, firmware, middleware and driver development, file system development, and many more. C is used effectively in various specific domains. It is a free formatted language and not a strongly typed language. Efficiency and portability are the important considerations. Library facilities play an important role in C programming language. Now, coming to embedded C. Embedded C is an extension of C language and it is used to develop microcontroller-based applications. Number systems which are used in embedded C are decimal, octal, hexadecimal, and binary. Data representations are done using bit, byte, or word. Data types used in embedded C are integral, which are of char or integer type, floating point, which can be of float or double. Conditional constructs in embedded C are single iteration, if else, if and switch cases, multiple iteration, which are while, do while, or for, unconditional statements, which are continue or break. Operators. Operators operates on its operands and returns a value. Operators are of different types such as arithmetic operator, logical operator, relational operator, assignment operator, bitwise operator, etc. Coming to arrays. Arrays are collection of data of same data type. Addresses are sequential in an array. First element with lowest address and the last element with highest address. Pointers are embedded in data structures such as arrays, structures, and unions. Parameter passing mechanism in function is done by passing the reference using pointers. Pointer that is assigned a null value is called a null pointer, which is pointing to nothing. Now coming to functions. Functions performs a specific service. Parameter passing can be done by pass by value or pass by reference in functions. Strings. Strings are contiguous sequence of characters, easily stores ASCII and its extensions. Storage classes are auto, register, static local, static global, and extern. Preprocessors are header files and source files. Now coming to another main topic, which is microcontroller. Microcontroller is an integrated circuit which is capable of being programmed to perform a specific task. Embedded inside devices used to control the actions and features of a product. All components are embedded in a single chip. They are less flexible and have less design complexity. Things to be noted when choosing a microcontroller are its application, that is where to be applied, its performance and price, availability of tools, as well as special capabilities. Now coming to microprocessors. A microprocessor is a computer processor wherein the data processing logic and control is included on a single integrated circuit or a small number of integrated circuits. All components are separate, they are more flexible and have more design complexity. Now coming to embedded system, which is my project, which is my internship. Embedded system is any combination of hardware and software which is intended to do a specific task can be called as an embedded system. A general purpose system is used to perform large number of tasks whereas an embedded system is used to perform a specific task. Challenges in embedded system are efficient inputs or outputs, code optimization, and testing and debugging. Categories of embedded systems are as follows. First is standalone system, under which slave system. These systems are not intelligent even though these are embedded systems. This system cannot take action by their own. For example, semi-automatic washing machine. Second, independent system. These systems can take action by their own. For example, driverless car. Real-time system. These systems are time-bound systems which will take action on a specified time. Failures in this system are not acceptable. For example, airbag system. Network system. The systems which are connected to the network are called network system. For example, home security system. Mobile system. The systems which are movable are called as mobile system. Example, robots. Real-time aspects. First is hard real-time. Hard real-time aspects should meet its deadline. They are life-critical application. For example, pacemaker. Firm real-time. Similar to hard real-time, soft real-time. They can have tolerance in time for meeting its deadline. Now, coming to project description. This project is based on microwave oven which is used in our daily routine. Microwave oven is proposed in which the food status determines the time required for reheating or even cooking the food inside microwave, instead of speculating the length of time required to achieve desired status. It is real-time temperature monitoring system. In this project, we used to learn that how microwave oven works. This project is totally implemented using simulation software and some module by creating a prototype. It works similar like a real microwave oven. Modes of microwave oven. First is micro mode. In this mode is used to cook food in a traditional way. It uses a maximum power of 900 watt. In this, the maximum time that you should set for cooking is 60 minutes. Second is grill mode. This mode is used to cook meat and bread. It works as the micro mode, but the purpose is to cook meat and bread. User can set time as per the cooking time of the meat. Now the third is convection mode. In this mode, user can set the oven to preheat for a particular temperature, and it takes 3 minutes to preheat the oven. After preheating is done, then the user can set the time as per the requirements. Now the fourth is start mode. It directly starts for 30 seconds countdown. It can be used for short period time cooking. Now the requirements in my project are MPLab X IDE, XC8 Compiler, PicSimLab for simulation, PIC16F877A microcontroller, 16x4 CLCD, tactile switch, matrix keypad, timer module and fan module. First one is PIC16F877A. It has 40 pins. It has 5 ports in total: port A, port B, port C, port D and port E. It supports serial communication, for which it has 2 pins, transmitter and receiver. We can receive data from receiver and transmit data from transmitter. We have to place a crystal oscillator ranging from 4 MHz to 40 MHz. Moreover, we will also need some programmer or burner to upload hex file. This is a pin diagram of microcontroller PIC16F877A, and this is a block diagram. Now coming to CLCD. CLCD stands for Character Liquid Crystal Display, and they are of 2 types, 16x2 and 16x4. We are using 16x4. It is used to display all ASCII character and symbol, and it has 16 interface lines. D0 to D7 are data lines. It has built-in controller. It has its own RAM and ROM so that controller can execute the instruction and data. RS line, also called register select line. When RS value is 1, it is data select line. When RS value is 0, it is instruction line. Tactile switch. Tactile switch is a switch whose operation is perceptible by touch. This switch is used to select the mode of operation and to enter the temperature or to enter the time in our project. This switch will produce a bouncing effect. Spurious pulse detection while pressing or releasing the tactile switch is called bouncing effect. There is a metal plate and terminal. There are two types of triggering methods. First one is edge trigger, second one is level trigger. Now coming to matrix keypad. This is a keypad in which number of tactile switches are connected in row and column concept. This is used when more number of user inputs are required and still want to save some controller input-output lines. These keypads are most commonly used in telephones, calculators, digital lockers, etc. In the cooking mode, the matrix keypad keys are used to select the respective modes. This is the diagram. Coming to timer. Timer is an important application in any embedded system, which is a default peripheral which maintains the timing of an operation in sync with system clock or external clock. It has many applications such as measuring time and generating delays, etc. Timer or counter is a software designed to count the time interval between the events. It has three modes like first PWM or pulse generator, second counter, and the third one is PW or PP measurement. Resolution, which is also called as register width, 8 or 16 bit, etc. Here toggling of LED is done using 8-bit resolution. Tick is referred as the change from one number to another number. It may be up count or down count. Quantum, which depends on the system clock setting, is the measure of time which is responsible for tick. Scaling may be a pre-scaler or post-scaler, maybe 1:1 or 1:2. The timer is set with matrix keypad star to clear and hash to enter. Now this is a fan module. As is implied by the name, cooling fan module is a device in a car that controls the temperature in the engine by regulating the speed at which the fan motor rotates. This creates a cooling effect in the engine by preventing it from overheating. Now coming to interrupts. An interrupt is a communication process set up in a microprocessor or a microcontroller in which an internal or external device requests the microprocessor or microcontroller to stop the processing. Then the microprocessor or microcontroller acknowledges the request and attends to the request. Goes back to the processing where it was got interrupted. ISR. ISR stands for Interrupt Service Routine. An ISR is a software routine that hardware invokes in response to an interrupt. ISR attends to the request of an interrupting source by clearing the interrupt flag and should save contents that may be affected by the code in the ISR. It must be terminated with the instruction RETIE. When an interrupt occurs, the microprocessor completes the instruction being executed, then it disables global interrupt enable, places the address from the program counter on the stack. Now coming to my project working, first we need to build the hex file in MPLab X IDE software and compile using MPLab XC8 Compiler. Then in PicSimLab software we load the hex file and simulate it. In PicSimLab we need to choose the PIC Genius board and the microcontroller which is to be chosen is PIC16F877A. This is a picture of my microcontroller on which I have made a microwave oven. Thank you. Now I will come to the demo of my project which I made during my internship. This is MPLab X IDE on which we used to do our code. First we type our code in embedded C. This code is then built from here. After building, we get the hex file. This hex file we need to upload in the PicSimLab. From here we load the hex file. Now my microprocessor and my microwave oven is starting. Now I will first choose the convection mode. Here we need to type the input for temperature. I will type it as 45 and using the hash key I will enter it. I have set my time as 180 constant, that is 3 minutes. Now my preheating is done. I need to set the time. Let us set it as 10. Then enter. Now the fan is started. Now we will come to the micro mode. We will select 1. It has a maximum power of 900 watt. Now again let us select this 10. Enter using hash. Again the fan is started, timer started. We will wait for 10 seconds. Now time's up. Again we will come to the grill mode. Again we need to select the timing. Again let us select this 10. Then enter. We can pause it using the 5 key. We can stop it using the 6 key. And now we can also start it. The last one is start, which we can do using the start key. Hold. The timer has started. It is prefixed as 30 seconds, so it has started. We can stop it using 6. It is all stopped. We can also turn on the LED like this. This is a fan. This one is PIC16F877A microcontroller. These are LEDs. These are matrix keypad. These are CLCD 16:4. This is a display. This is all about my project. Thank you, Emertxe, for giving me such a valuable knowledge. Thank you so much.